Hi everyone! So it's me again. So our topic is about Aristotelian, Galilean, and the Newtonian concept of motion. In the quarter full week 2 in the physical science for the grade 11 students. So before we start discussing, let me introduce myself first. I am Emperado. Based on from the photos above, our current understanding on the physics of motion did not happen overnight. Instead, it is gradually developed as philosophers take up previously held philosophies and improve on it, or give critique identifying possible weakness or inconsistencies with observation. And Galileo's two major contributions to modern physics were the law of falling bodies and the law of inertia. Inertia of motion of an object means that this motion solely be changed forces acting upon it. Gravity accelerates all objects equally regardless of their masses or the materials from each from which they are made, and this is a cornerstone of the modern physics. Galileo discovered that the law of inertia rather, but he did not name it. So Aristotle versus Galileo. Aristotle believed that the pendulum slowed down as it approached its resting place. Believe heavier objects feel faster than smaller ones. Earth was center of the universe. So for the Galileo, shown up a pendulum does not slowly down, called the law of the pendulum, shown that all object falls of the same speed with a homemade telescope monitored the movement of the stars to show the sun was the center of the universe. The four types of the There are four types of the terrestrial motion. So first, alteration. Simply a chemical or physical changes. So that is a alteration. For the vertical, for the number 2, the vertical or natural motion. And for the third, the horizontal or violent motion. And for the fourth, celestial motion. Philosophical, these motion are by their very essence different from each other. The closest to each other will be natural motion and the violent motion. Natural motion in relation to the four elements mother of Aristotle and their natural position in the Earth being at the middle of it. Hence, object made more than Earth falls faster than those made more than fire or air rather. The concept of violent motion is related to the term violent, being the state of motion that prevents the attainment of natural progression of motion, either frustrates or thus against the natural motion. It is caused by external forces applied to the object. Aristotle thought that the maintained motion at external force must continue to be exerted on the object. And for the projectile motion is a force of motion experienced by an object or particle that is projected near the Earth's surface. The moves along the curved path under the action of gravity only. This curve was shown by the Galileo to be a parabol, but may also be a line in the special case when its thrown directly upward. Galileo understood that the projectile's path is a combination of horizontal and a vertical motion. Galileo understood that a vertical motion does not affect horizontal motion. An object projected horizontally will reach the ground in the same time as an object dropped vertically. The path of any projectile is a parabol. Keep in mind that the natural philosophers had to base their explanation of motion as a prevailing the philosophical standpoint, while Galileo is a popular known to have finally nailed the following Aristotelian thesis on motion. Previous ideas and even experimentation has already been done. For Aristotelian natural motion, largely vertical motion, falling or rising. The violent motion largely associated with horizontal, hence projectile motion, are two motion of distinct nature. Example, the hammer and the feather drop at the same time. On Earth will not be accelerate at the same rate because of air resistance. And for the Aristotelian, a constant amount, the number to Aristotelian, the constant amount of force is needed to be applied to objects to keep them moving in horizontal motion. Example, the one on the moon, which has no atmosphere. Both objects will reach in the ground at the same time. However, it can be credited to a Galileo to qualify the rate of fall by the measurement of distance and time and plotted it graphically. Galileo's experiment of falling bodies. Galileo climbed all of 352 steps of leaning towers of Pisa, where he took up with the two balls, each with different weight. Once he was on the top, he dropped both balls to see which would land first, even though their weight were not the same. They hit the ground at the same time. From the experiment of Galileo, found that the object fall to the ground at the same rate, regardless of weight, unless things like air resistance change their rate. The violent motion. This idea said that the only motion that requires a force is a violent motion. For example, pushing a book along the table or lifting a book. The infamous leaning tower of Pisa experiment of Galileo may not be true but only likely to have been done by Galileo. Other philosophers before him mentioned a very similar observation. Galileo allegedly demonstrated the equal rate of fall of objects differently in weight. The philosophical argument reduction of the absurdum method used by Galileo in showing the Aristotelian proposal that heavier objects fall at the same rate must be false, and that the only plausible explanation is all objects fall at the same rate. Galileo instead of slowed down the fall using the graph by plotting the position against time and the same time increasing the slope. One can deduce that the resulting rate of fall or acceleration approaches a single value. So in uniform acceleration of objects in a vacuum, the notion of uniform acceleration of objects in a vacuum will be better understand if we could first recall or understand what is acceleration and what is vacuum. Acceleration is a vector quality that is defined as the rate of which the object changes its velocity. An object is accelerating if it is changing its velocity. For example, the data belong to experiment representative of the northward moving acceleration object in a velocity in changing over the course of time. In fact, the velocity is changing by the constant amount of negative 10 millimeter meter per second. In the each in in each second of time, any time an object velocity is changing, the object is said to be accelerating. It has an acceleration. The acceleration of the object equals gravitational acceleration. The mass, size, and the shape of the object are not a factor of describing the motion of the objects. All objects, regardless of size, shape, and weight, fall freely with the same acceleration. In the vacuum of the cotton balls falls at the same rate as a metal ball. Knowing that acceleration, we can determine that the velocity of location of any on the free falling object at any time. Such a wonderful observation that all objects fall with the same acceleration in a vacuum was first proposed by the Galilei. Nearly in 400 years ago, Galileo conducted experiments using a ball that is inclined plane to determine the relationship between the time and the distance traveled. He found that the distance depended on the square of the time and that its velocity increased as the ball moved down in the incline. The relationship was the same regardless of the mass of the ball used in the experiment. The experiment was successful because he was using a ball for the falling object and the friction between the ball and the plane was much smaller than the gravitational forces. He knew that falling objects increase their speed as they go down. This change in speed is acceleration. However, Galileo did not have only equipment to measure this change, so that he did not use inclined planes to lessen the acceleration of moving bodies rather. Through such inclined plane, he was able to figure out the change in speed. Newton's inertia and Galileo's assertion. What is the Galileo's assertion on motion? So Galileo Galilei was one of those who initiated the concept of inertia before the Newton come up with the law of inertia. In this experiment, he found out that when the ball rolled down in the inclined plane, its speed of maximize or the increases and decreases speed and it was rolls upward on the inclined plane in such scenario where the ball decreases speed when going up the plane and increases speed when going down, but respectively gradually taking object. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to the change its state by the action of external force. This is normally taken as the definition of inertia. The key point here is that there is no net force acting on an object if all the external forces cancel each other out. Then the object will maintain constantly velocity. If that velocity is zero, then the object remains there of rest. If an external forces is applied, the velocity will change because of the force. So that's all. Thank you for listening and happy learning.